let's start with the official presentations for this event. And let's welcome our first presenter, who is Markus Bradke from GFZ-Potsdam, who will be talking about the IGS network, current and future work.
Thanks, Myra, and good evening from Germany. I'm just pulling up my presentation. Okay, can you all see it?
Yes, perfect.
Okay. So I'm very excited to give you an introduction and an overview into the IGS infrastructure tonight, into our network and into the work of the IGS infrastructure. And this presentation is mainly dedicated to the ones who are not 100% familiar with the IGS infrastructure, but I promise that there might be some interesting facts, even for those who grew up with our service. So let's dive right in. So by taking a look at the organization diagram, I like to stress the importance of the infrastructure. As you can see, it already takes a major portion within the IGS organization. It's the backbone for everything we build and we produce on a daily basis. In general, the infrastructure consists of the network, the data centers on various levels, and the infrastructure committee. And all of those components have a coordinator in place. All roles and components are dependent on each other and require a lot of communication and coordination. And in this presentation, I like to introduce the network and the work of the infrastructure committee. Pat Michael will give you an insight into the life of one of the biggest data centers later tonight. Okay. Okay. So let's focus on the committee and our tasks first. We are a forum of professionals from the network and the station operators down to data center and GNSS IT professionals. And we also include ex officio members, that means chairs and coordinators from other IGS working groups, so that we keep the coordination up. We develop policies, standards, guidelines, and recommendations. And yeah, we maintain and improve the GNSS data and information systems upon which the IGS product quality and responsiveness relies on. And in general, we ensure the overall effectiveness of the service. The committee continuously works together with all of the IGS components, from the governing board over the analyzer centers and data centers down to the station operators. And the main focus is to keep the level of high quality GNSS data that we have now and even improve it. We are also established task teams, and we are also participating in external working groups. So we have a task team that deals with or that coordinates station proposals between different networks. We work together with the Central Bureau on the IGS Site Log Manager. We built a little team that deals with data center security, and I guess Pat will give you some more information later on. And I'm personally involved in the GGOS DOI working group that deals with digital object identifiers and how we could tangle those between different networks that already have DOIs and contribute to the IGS. And we meet on a quarterly basis. So this should be enough as a quick intro to the IC. Now I'd like to give you the status quo of our network. So we have 505 registered stations as of August 24. All of the statistics that follow are based on that date. We have 246 overall agencies. This includes local and supporting partners. And we have 131 responsible agencies. So the agencies that are actually responsible for the maintenance of the stations. And they mainly come from research and federal surveying. Interesting is that 70% of the network is covered by 20 agencies, and 6 agencies contribute with 23 to 60 stations, which already makes a big portion of the network with 41%. So the IGS is the umbrella for a cooperatively operated global network of ground tracking stations. And the network is quite homogeneously distributed, but we can also note a bigger gap in the Sahara region and in Siberia. And from the 505 registered stations, 88% are currently active, and 74% of those make their data available in RHINEX 3, which is a great improvement if we look at the availability rate of RHINEX 3 over the years. So we started with 12 stations in 2012, and we could improve this rate between 5 and 10% year by year since then. This also shows the commitment of the participating agencies to support the format, which is the base for the exchange of multi-GNSS data. Okay, a different view on the network allows this plot. It shows the currently used antenna models in the network. We have an overall of 54 models from 15 different vendors, which is quite a variety. But if we look a bit closer and focus on the models that are installed on at least 20 stations, this number goes down to 10 models. And dominating in the network are Jawad, Leica, Septentrio, and Trimble. So the same big players and even more noticeable we find for the receiver models. So Leica, Jawad, Septentrio, and Trimble with their flagship GNSS receiver boards are dominating here. So on the one hand, we can be confident that the data is recorded by high quality and mostly up-to-date receivers. And on the other hand, we can ensure some kind of reliability by the use of different receiver models, which ship with different software. So one of the strategic goals of the IGS is to achieve multi-GNSS technical excellence within all of the components. So before you can analyze multiple systems, you should have applicable data. And in a big effort by the IGS ACs, Repro3 was the first reprocessing campaign that included Galileo as third system. So it's worth having a look at the station distribution. And 70% of the stations already support Galileo, but there are still some stations that provide data in RHINEX 3 and RHINEX 2, I'm sorry. If we go one step further and check the availability of Beidou, we can see that there's still room for network improvements. Russia and the north of Africa are basically Beidou free, Natural Resources Canada is currently working on upgrading their network to full multi-GNSS, so that will close the gap in the east of Canada. And I would also like to mention that some of those stations additionally track the Japanese QZSS and the Indian NAVIC satellites. So, okay, another view on the hardware side shows an interesting dependency. If we look for the antenna models that support at least 4 systems, so almost 60% of the GREC-capable stations are equipped with one of the 5 dominating antennas. So from Javad, Leica, Septentrio, and Trimble. And this dependency is even clearer for the receivers. So 90% of these stations are equipped with one of the 6 dominating models. As I said earlier, this gives confidence that we work with high quality data on the one hand, but it also shows that we are well positioned in terms of reliability on the other hand. So we are not just dependent on 1 or 2 major receiver vendors. Okay, the last map I'd like to show you tonight is the multi-GNSS real-time map. And this is obviously where most of the improvements can be made. Currently, 41% of the IGS network are providing data in real time. And we see the same gaps in Russia and Africa. And surprisingly, additionally, in North America, Latin America, and Southeast Asia, there are currently multiple stations from India, Ethiopia, and Indonesia proposed. And we are in contact with UNAFCO to include more of their US CORS stations into the IGS network. On the positive side, most of the stations are already tracking at least 3 systems. Okay, on the last 2 slides, I'd like to come back to our current activities in the infrastructure committee. In the last year, we could initiate that the IGS provides coordinate solutions for all IGS stations. This has always led to confusion in the past and to questions in the community that we wanted to fix. And there were around about 40 stations missing that could be added by GFZ and are now available in the final products. We would like to increase the number of multi-GNSS and real-time stations by active outreach. And this forum that we have tonight is one great opportunity for an active outreach. We would like to provide support to station operators in the less represented regions to build capacity and capability. And we would like to ensure that the IGS network has a consistent global coverage. We are also working on new and updated guidelines. So we are working on a new CORS guidelines, currently known as IGS site guidelines, on data center and real-time broadcaster guidelines. And we forwarded the request to the analyzer centers to create analyzer center guidelines. Yeah, and all of the last 3 points fit well into the goals of the IGS strategic plan to achieve multi-GNSS excellence, to strengthen outreach, and to build sustainability and resilience. Furthermore, I'd like to introduce you to some upcoming web services and software applications that will be useful for the GNSS and for the IGS community. So from the Central Bureau, there are some web service implementations going on. One is the Site Log Manager, where we will hear an update later on. The Central Bureau is also working on station monitoring plots and time series plots. that were formerly hosted by IGN and by Paul Ribichon. And at GFZ, we are working on a new satellite meter information system, which will be based on the MJAX metadata file, and it will include antenna PCOs and notice advisories from the satellite operators. And we are working on a station meter information system that will implement geodesy ML. And both systems will replace the current SEMISYS in the long term. They will be open source, and you can access them with a REST API or with just a graphical user interface. And we hope that it will be available by the start of next year. And my colleagues are also working on a quality check add-on for GFZ-RNX. Okay. I look forward to see you in Boulder 2022, hopefully. And yeah, thank you very much.
Thank you, Marcus. It seems that we have a couple of questions. I think Ryan commented on it, but I'm going to give you the opportunity to answer, Marcus. So how is data returned from the remote stations, Antarctica and Greenland, Macquarie Island, and with what latency?
Yeah, I think Ryan answered that correctly. I mean, they're mostly VSAT communications. We don't really have. I think we have one in Antarctica, one station, and yeah, the latencies are within that range that he mentioned of 600 milliseconds.
Okay, well, let's thank once again Marcus, and if you have any additional questions, we can have some more discussions at the end of the event.